Hello everyone, good evening to one and all of you. Good evening. Yeah. Let's start today's class. Today will be our second day on pandas. Yesterday I introduced a bit about pandas and told you about the basic functionalities. The last topic that I taught you was probably how to replace the null values, which are also known as inane values in Python. We will just start from that, and we will continue from there only. Okay. Yes, this is the notebook that I will be using for today. So the topic is dealing with NaN values. As mentioned earlier, before we can begin training our learning algorithms with large data sets, we usually need to clean the data first. Just wait a minute. Just wait a minute. I think I must put my earphones on because to prevent any disturbances from the background. Fine. Is my voice audible? I guess my voice should be audible quite clearly. Fine, fine. So dealing with NaN values, as mentioned earlier, before we can begin training our learning algorithms with large data sets, we usually need to clean the data first. This means we need to have a method for detecting and correcting errors in our data. Now, while any dataset can have many types of bad data, such as outliers or incorrect values, the type of bad data we encounter almost always is missing values. As we saw earlier, pandas assign NaN values to missing data. In this lesson, we will learn how to detect and deal with NaN values. Okay. So basically what I'm trying to say is, whenever you get any live data or a data from a real world application, that data is never perfect. There are many errors from it. Suppose you are conducting an experiment that is a live experiment, and the data that you will get there from it is live data. Now some values will be missing from it. Okay, like a like a full data set, like it's not possible to get a perfect data set. Okay, like generally it happens, some data will be missing, some will be erroneous result, and so on. So this type of things will be present there. The most common among them is missing values, that is a presence of NaN values as we call it in Python. Okay, clear up to this? Fine. Attendance link, you will get it later. So I also told you in yesterday's class that apart from the basic data structures that we have in Python, like list, tuples, set, dictionaries, we also have two additional data structures only for pandas. They are series and data frames. So first we will create a data frame which has some NaN values or missing values in it. The first line that we write is import pandas as PD, because if we don't import library, we can't use the library. So we must first import it. Import pandas as PD. We create a list of Python dictionaries. Items 2 equal to bikes 20, pants 30, watches 35, shirts 15, shoes 8, suits 45, watches 10, glasses 50, bikes 15, pants 5, shirts 2, shoes 5, suits 7, bikes 20, pants 30, watches 35, glasses 4, and shoes 10. So there are basically, there's a list, okay, list of Python dictionary. So from here to here is one dictionary, here to here is another dictionary, and here to here is a third dictionary. How can I understand whether when a new dictionary is starting, a dictionary is always started by this brace and ended by this brace. So from here to here is one dictionary, and from here to here is the second dictionary. Okay, so this is how we will understand when a dictionary basically begins and when a dictionary ends. We create a data frame and provide the row index. Stored items equal to pd.dataframe, items 2 index equal to store 1, store 2, store 3. Okay. We then display the data frame. So after basically executing this list of dictionaries, we are basically converting the entire thing into a data frame. I told you yesterday that the syntax for creating a data frame is pd.dataframe, then within bracket data comma index. So this is the data and this is the index. Index is store 1, store 2, store 3. So let us execute this cell and see what happens. So we are getting somewhat like this. Here are the indexes, store 1, store 2 and store 3. Here are the dictionary keys: bikes, pants, watches, shirts, shoes, suits and glasses. Unique dictionary keys. Okay, so yeah, I guess there is no problem in it. In cases where we load very large datasets into a data frame, possibly with millions of items, the number of NaN values is not easily visualized. For these cases, we can use a combination of methods to count the number of NaN values in our data. The following example combines the .isNull and the sum methods to count the number of NaN values in our data frame. Okay, so here in this case you can see that we have one NaN value or missing value in our dataset, that is here in the store 1 index glasses column. Okay, so this is our NaN value. But what if you get a very large dataset containing millions of items? You can't easily visualize the NaN values using your naked eye. So that means you must have some commands which can do the thing for you. So for that case, we use a command .isNull and the sum command to basically count the number of NaN values in our data frame. How it is used? Let us see it here. So this was our data frame name, that is stored underscore items. So stored underscore items dot is null in bracket, like then we open the brackets and close it. So what will this give? It's basically giving that in which part there is a null value is null. Okay, so as you can, like, if you look at the name of the method sometimes, or the name of the function, you can easily guess its return type, whether it's boolean or integer or float. Okay, so that's how you guess it. False true, like this. And in pandas, logical true values have a numerical value 1 and logical false values have a numerical value 0. Therefore, we can count the number of NaN values by counting the number of logical true value. Okay, are you getting my point, what I'm trying to say? That this result will give that whether in a particular place, whether in a particular cell, my value is missing or not. If it is missing, it will give the result true. If it's not missing, if it gives the result false. Fine. Now, from here, you cannot understand how many values are missing. Can you? You cannot. So, to calculate the number of missing values, you need to add something extra to it. And here comes the dot sum method to our rescue. That is, if you write as x, like suppose we initialize a variable to store underscore items dot is null dot sum, then you print it. So it will become something like this. It will first write the columns, write the column names, and in each column it will specify how many missing values are there. So in the every column other than this glasses is complete and has no missing values in it. Only glasses one missing value in it. So this also represents it. Okay, suits also has one missing value. Yeah, here it's true. So it's also one missing value. And shirts have a missing value here, and yeah, that's why it's one. So only shirts, suits and glasses have one missing value each. Fine. Send the Google Colab. All the notebooks that I'm using now, I have uploaded it in GitHub and shared the GitHub link in the first day only. Okay, so if you have attended the first day or you have attended the boot camp that day, you would have got the GitHub link. And this GitHub note and these notebooks are only I'm executing it in Colab. Okay, so you can see it there. In order to count the total number of logical true values, we use the dot sum method twice. We have to use it twice because the first sum returns a panda series with the number of logical true values along columns as we see below. So this gives the number of missing values in each column. What if we want to find out the number of missing values in a total in a just wait a minute. Just wait a minute. Anuj. Okay, so D type, there is a question named D type int64. What is the meaning of it? D type int64 is the meaning for integer. Okay, is the meaning for integer. That means the value that the data that is having is of integer type, nothing else. Fine. So, but what? So, getting back to where I was. Sorry for the disturbance. Actually, dot is null dot sum gives the number of values that are missing column wise. But what if you want to find the number of missing values on a total, like on a total basis, like in the total data frame, the number of missing values? So at that time we have to do is null dot sum dot sum. So there we will get the total number of missing values, that is 3. Let's execute this line also and see what are the things that we get. Fine. The second sum will add up the ones in the above panda series. That's what I told just now. So instead of counting the number of NaN values, we can also do the opposite. We can count the number of non-NaN values, and we can use this by using the dot count method. So now if we want so now we have seen the number of missing values, we can find out in this way. But what if we find out the number of non-missing values? There is a number of complete values. If you want to find out that, so what thing we shall use? For that purpose, we have dot count method. Store underscore item dot count gives the number of the non-NaN values. There is a number of not missing values in our data frame. So dot is null is for missing and dot count is for not missing. Is it clear? Okay. Now that we have learned how to, so this is also giving that type of results only. Like for C, for example, here bikes you have 3, pants 3, watches 3, and so on. So yeah, that's how. So that means the bikes have 3 not missing values in them. You can understand it easily. Now that we have learned how to know if our data set has the next step is what to do with them. In general, we have 2 options, either to delete them or to replace them. In the following example, we will show you how to do both. We will start by learning how to eliminate rows or columns from our data frame that contain any NaN values. The drop NA access method eliminates any rows with NaN values when access equals 0 is used, and will eliminate any columns with NaN values when access equals 1 is used. Let's see some example. So now when you have detected the number of, okay, so can we use sum on count? Yeah, you can use sum on count. You obviously can use sum on count. Let me show it to you. I am showing it to you here only. I'm not writing the entire thing. See, then when you are applying dot sum, so the total number of not missing values are being shown here. Okay, so that's what happens when you use sum on count. So now we have seen how now we have learned basically how to find out the number of missing values and the not missing values in our data set. Now we should know that how to deal with them, like what to do with them. In general, we have 2 options. We can either delete them or we can replace them. Okay. We'll start by learning how to eliminate rows or columns from our data frame that contain any NaN values. Now, our first method will be eliminating. Eliminating means deleting. dot drop NA axis method eliminates any rows with NaN values when axis equals 0 is used, and will eliminate any columns when NaN values with axis 1 is used. So this dot drop NA method helps us to drop the column or the row which contains the missing values. If we use axis equals 0, it's basically dropping the row with missing value, and if we are using axis equals 1, it's dropping the column with missing values. Fine. Yeah. So let's use it here. Store underscore items dot drop any axis equals 0. So we are basically removing all the rows which are having missing values. Let's look at our original data set once. So we are having missing values in our first row. We are also having missing rows in our third row. So technically, after applying drop NA, only the second row should be left. Let's compare it with the results we are getting. So here's store underscore item dot drop NA axis equals 0. Only the second row, store 2, it's appearing here, and since it does not contain any missing value, only it is being present. Similarly, if we drop any columns with NaN values, only these 4 columns are left which don't have any missing values, and hence these are only displayed. So I'm executing this also, and somewhat like this appears. Fine. Yes. So notice that a drop NA method eliminates or drops the rows or columns with NaN values out of place. This means that the original data frame is not modified. You can remove the desired rows or columns in place by setting the keyword in place equals true inside the drop NA function. Now instead of eliminating the NaN values, you can replace them with suitable value. What it is trying to tell is that you cannot entirely delete the missing values from the original dataset if you want. Just wait a minute. Then you can do it in 2 ways. One option is that either you can set the keyword in place equals true. In place keyword I also have shown it to you earlier in your first Panda session. There also I first used the word keyword in place. So either you can set in place equals true inside the drop NA function, or you can do it in the way that I'm showing it to you. Will it return no value if all rows have one or more elements as in? Obviously, if it does not have any row or column that, or maybe rows, that does not have any NaN value, then it will return nothing. It will just show blank. Okay, so that's what it is. Let's see it here. Instead of eliminating NaN values, we can replace them with suitable value. Like we could choose, for example, to replace all NaN values with the value 0. Now what I told that, if you have replaced NaN values, you have 2 options. Either you delete the entire row or column, or either you replace it. Now replace it with what? So for example, some may think that, okay, if we could replace the missing values with at least 0, okay, if we could replace the missing values with at least 0, then instead of NaN, some value will be there. 0 is a wrong value, we all know that, but some value at least it will be there, and not taking the error or the precision accuracy into our consideration, it will still work in our ML model. But if you have NaN values, it cannot work in ML model. So at least to make the model workable, you can, some may think that, okay, for the timing, let's replace the NaN values with 0. So to replace it, you can write it like this, that store underscore items dot fill NA 0. That is, it is filling all the NaN values with 0. Understood? Fine. We can also use the dot fill NA method to replace NaN values with previous values in the data frame. This is known as forward filling. When replacing NaN values with forward filling, we can use previous values from columns or rows. The dot fill NA method equals to ffill axis. We'll use the forward filling ffill method to replace NaN values using the previous known value along the given axis. Let's see this. Now, there is also one method known as ffill. Ffill is what? Like ffill NA to be precise. Ffill is forward filling. That means replace the NN values with the forward filling. That is the previous values taken from rows or columns. Suppose here we had our NN value, right? So here we will fill it out. Okay, let's execute this. We're getting somewhat like this. Just note the store 3 shoes. Here it's 10, right? Here it's 10. Look at the original dataset once. Okay, not shoes. The suits store 3 was NN. So let's see the suits store 3 value. Where it's here. Suits store 3 value is also given as 7. Where did it get the 7 value? It took the previous value and replaced it here. Okay, any other NN value that we have, suppose here one missing value was there in shirt store 3. So what it did, it took the previous value and replaced it here. So ffill means forward filling, that is it takes the previous value and fills up the next NN or the missing value from there. But it did not replace the NN value here. Why? Because we don't have any previous value before this. This is the first value of the column and it's a missing value. So we don't have any option to take the previous value and replace it with. So here is the main concept. अनुज अटेंडेंस लिंक मेरे बना के दे देना भाई. We see that in this case all the NN values have been replaced with the previous. Okay, now next thing. Notice that NN value is stored in store 1 didn't get replaced. That's because there are no previous values in this column. Since the NN value is the first value in that column. However, if we do forward filling using the previous row values, this won't happen. Let's take a look. So it's telling that we used axis equals 0 in that case, and since there was no previous row, so that's why that NN value did not get replaced. But what if we use axis equals 1? So if we use axis equals 1, that means instead of the previous row, the previous column value will get replaced in that. So here what is happening is, first of all, see that there is no NN value, the missing value is left. Everything is filled completely. So in store 1, let's see this one, that like here in glasses store 1 this value wasn't replaced first of all. So this NN value is 45. Where did it get this 45 value from? It took this value from the suit store 1. That is, this 45 value is going here and 45 is like replaced. Did you understand it? We see that in this case all the NN values have been replaced in the previous row value. Similarly, you can choose to replace the NN values with the values that go after them in the data frame. This is known as backward filling. Now you first learned about forward filling. Now you learn about backward filling. The dot fill NA method equal to backfill axis will use the backward filling. There is a backfill method to replace NN values using the next known value along the given axis. Just like with forward filling, we can choose to use row or column values. The store underscore items dot fill NA method equals backfill axis equals 0. Store 1, 20, 30 and like this. So what it's doing is it's taking the back just a next known value. Okay, the next known value is replacing it with the missing value. So just see here, just look at this part. Here we had a missing value in the original dataset, right? The NN value was present here. 50 is shown right now. Why? Because we used axis equals 0 and method equals backfill. What it did is it took the value on the next row. The next row has 50 value and hence the 50 value is going here. Is it clear? So when x is equals 1, then there is no chance of any element remaining in a n. No, if x is equals 1, there may be chance of remaining in a n. In this dataset that I used, there is no chance of remaining in a n. But suppose I'm giving you an example. What if there is a missing value in the first column and you are using a method equals to forward? Then what it will do is it will try to find out any value from the previous column of the first column. Now first column has no previous column, right? So if first column has no previous column, then it will take, then from where it will take the value? It will remain blank. In this case, our situation was favorable and we were done, but not the case with every time. Can we use backfill and front fill at the same time? No, we cannot use backfill or front fill at the same time. You can either use backfill or front fill. So here you are using backfill and store 1, store 2, store 3. These are the values. X is equals 0. In the last row you still have NaN values. Why? Because there is no row after the last row. Are you getting my point? There is no row after the last row, and hence there are no values to replace it with. Fine. And method equals backfill and x is equals 1. If we write that, in the last column the NaN value is still there because there is no column after this last column to replace the value. Notice that dot fill NA method replaces or fills the NaN values out of place. This means that the original dataset data frame is still not modified. So dot fill NA is also replacing the values out of place. That is, the original dataset is not modified and is still remaining intact. You can replace the NaN values in place by setting the keyword in place equals to using the fill NaN function. So for all the cases, the method to replace the value is in the original data frame is in place equals to true. By that we can make changes in the original data frame. Okay. We can also choose to replace NaN values by using different interpolation methods. For example, the dot interpolate method equal to linear axis method will use linear interpolation to replace NaN values using the values along the given axis. Let's see some examples. Store underscore items dot interpolate method equal to linear axis equals 0. So what it happens is that if you write method equals to interpolate, then it will just create a linear graph and try to see what are the values that are there. Like example, I'm just giving an example. Let me just give you an example. Let us look at the original data set that we are having. So this, suppose look at this data. Look at this two missing values. Store 3 shirts and store 3 suits. Try to remember it and just see what is happening here. These two values are filled up. How? But this value isn't filled up. So these two values are filled up because dot interpolate linear creates a linear graph using the previous values and tries to see if we move by that linear graph, what will be my next value. So it's creating a 8, 5 this graph, and my next value, not this one, this 15, 2, and the next value that we have by linear interpolation will also be 2. And for this example also, the next method we have, that is also be 7. So that's how it's going. Notice that the two NaN values in store 3 have been replaced with linear interpolated value. However, we notice that the NaN value in store 1 didn't got replaced. This is because the NaN value in the first value in that column, and since there is no data before it, the interpolation function cannot calculate a value. So if we don't have any data before it, how can we interpolate? So the interpolation doesn't take place. So what can we do to fill all the NaN values in one go? There is no as such direct method to fill all the values in one go. Okay, but I can tell you that there are better methods than this, which can make the work easier, But if you try to say in one go, I don't think there is such method. Maybe there are some complex fancy functions for that, but all the basics that we are teaching right now, there is no method to like for that. Okay, so attendance link you are wanting, let me give you that first. अनुज लिंक नहीं गया.
Yeah.
Just wait a minute. Just wait a minute. Okay, so the link has not come basically. As soon as it comes, I will share it with you. Fine. So, any problem up to this? If you have any questions regarding the content, you can ask me. So this is the attendance sheet link. I'm pinning this message. Try to fill it up. You will get the attendance for today. Okay. So yeah, this is all about today. And if you just want today's attendance, you can fill up the attendance sheet link. You will get the attendance for today. If you have any questions for today, you can ask regarding the content. Otherwise, we'll just meet next day with a new topic. Bye for today. Have a great day.